Thanks. This is me. You can find me on various places on the internet like everyone else these days. GitHub, Twitter, IRC. Find me afterwards, I'm sure. So first of all, I have to thank, I guess, two people. Number one, I have to thank, so I work for a tech company called Magnetic. Our home office is in New York City. We also have offices in San Mateo on the west coast of the US and in London. And thankfully for our conference policy, they fly me out here. I guess this is now my second EuroPython. And so fantastic conference. I thought this year was great. So I have to thank my company definitely for sending me out here. About 250 employees. We work in advertising. If you're interested, come talk to me. Afterwards, we run PyPy in production. We have been for probably about a year and a half now. Spark, Impala, a whole bunch of other fun technologies. Okay, so this is a talk about object APIs, not particularly talking about web APIs. I want to talk a little bit about, you wrote some library, some piece of code, and inflicted it on the world. And some sort of simple common pitfalls that come up when that happens. Now, inflicting it on the world might be a small world, maybe you're the only user, but then the person that you'll end up pissing off is probably you in a couple of months after you wrote it. So I suspect that some of these things will still apply. And I don't really want to talk very much at the high level. So I'm not really going to talk about high-level design stuff or abstract concepts and things like that. I'm sort of just going to pick 3 or 4 somewhat common specific things that tend to come up as examples for more general concepts. But there is sort of one general high-level thing that I think is worth keeping in mind, which is that someone who first comes to your library or who has used your library for a little while and then uses a bit more of it, comes in with some expectations, right? So they're a programmer, they've used other libraries, or they've used parts of your library. They're going to have some expectation for how some new part of your library works. And they might be surprised if they find out that it doesn't. And this play between being able to have some intuition about what a particular piece of code is going to do, and then some result that doesn't match that intuition, is often one of the things that I think causes frustration for people when they're using libraries. And so when you're designing things, I think it's important to keep that specific idea in mind. When you make choices, how do they affect the predictability for a given piece of code? So let's just sort of jump right in here. So I think the most agreeable classic example for something that can go wrong is type checking, right? I'm sure everyone has heard of duck typing. Everyone has heard, don't type check, don't do this sort of thing. So what's going on here, right? So you have some generic compute function unspecified here, which is going to do some very exciting computation, I'm sure. And before you do so, you have this is-instance check. You check to make sure that some numbers that you're being passed are sitting inside a list. And if they're not, then you're going to raise an exception. And so, people say, don't do that, don't type check. Why? What's the actual problem here? Or at least one of them. So possibly a way to say what the problem is here is what your function says that it needs isn't actually what your function needs. So of course, it's possible for your function to exactly need a list. But generally speaking, in the overwhelming majority of cases, that's not actually true. What you really need is some piece of functionality that you're going to rely on for the object that you're being given to have. Maybe that's that it's iterable. Maybe it's a sequence. At best, it's one of those things generally. And so by artificially enforcing that it be of a specific type, you're limiting the amount of extensibility that someone who might want to use this function has. And a user who sits there and finds such a thing is going to end up being pretty frustrated because there's very few ways to actually get around that, right? You have a function in front of you, it does exactly what you need. It just has a simple barrier in front of it that's saying you have an object that would work here, and there's an exception being thrown that's going to prevent you from actually doing what you want. So I think type checking is probably the most classic example of sort of an artificial barrier that you can put up when designing some particular piece of code. But let's talk about some other ones. So I should have mentioned to start with, there's probably, depending on your perspective, some heavy opinion in here, so I'm sure there will be things that people disagree on. But let's talk about type dispatch. So a couple of different talks at the conference have discussed graphs. So here's a simple graph, a couple of nodes, a couple of edges between them, and we're going to represent this for our fun graphing library, right? So let's create a graph class. So looks pretty much as you expect, at least on the top. You have a graph class. It's going to take some argument to actually construct it. And actually, what we're going to do here is there's going to be 3 separate kinds of arguments that we'll take. So we'll take a bunch of different representations and end up constructing from them a graph, because there's a lot of different ways that we might have our graph represented as data, and a lot of different ways that we might want to construct a graph. So possibly we have a list, in which case the way we'll interpret that is if you give me a list of 1, 2, and 3, those are probably the nodes that you want. So in your graph you say 1, 2, 3, that'll create you a graph with 3 nodes and no edges. Another possible thing that you might have is a dict, a mapping, which will probably be some adjacencies. So adjacencies are, you have a dictionary, it has a bunch of keys, so in your dictionary is the key 1, and its value is a list 2, 3, 4, and what that is interpreted as is node number 1 should exist and have connections to nodes 2, 3, and 4. So you can build up a dictionary that looks like that. A dictionary is your adjacency matrix, your adjacency mapping. Pass that into the graph class, and that will create a graph with those nodes and those edges. And maybe some third form that our graph might take that we might want to actually support is some form of serialized graph, right? So I guess in an artificial example, that might be JSON. So maybe you have some graph represented as a JSON dumped string that you want to support as a way of actually constructing a graph. In a more realistic case, there are varying formats for actually storing graphs in files and representing them as bytes. And so maybe you want to support one of those. So you're gonna take a string in, let's say, dot or one of those other formats, parse the string, and construct a graph via some format that you're gonna want to accept there. So we have these 3 different paths towards creating a graph. So what's the problem here? So the problem with APIs that do that sort of thing is, generally speaking, the person calling your function actually knows what they want, right? So you have one of those 3 things. You're someone using a library that does this. You know exactly which one of those 3 cases you are. You know if you're someone who has an adjacency matrix that you want to construct a graph from. You know if you have a file that you need to read and parse, and you know if you have a bunch of nodes that you want to create. And what these sorts of APIs do is they take someone who knows some information, throw it away immediately, and then try to guess it back again, right? So think about how that API is going to work. You're going to have an init method in your class. It's going to take an argument of one of those 3 types. It's going to say, is this case 1? If it's case 1, do this. Is it case 2? If so, do this. Is it case 3? If so, do this. So you've sort of artificially introduced some complexity there, where the person who's calling that function probably knows exactly which of those 3 cases he has, or she has, and knows exactly which of those he wants to happen. But you're just ignoring that information in your API and just telling someone, here, throw your stuff over here, and I'll guess for you which one you want. So don't create APIs that throw away information that someone might have. Just to make that a little bit more concrete, imagine that you have an API that's specified in the way I mentioned before. So you have some documentation, some prose probably, that says you can create a graph. I accept 3 formats, either a list of nodes, a dict with adjacencies, or a string which I will deserialize and create a graph from. what's going to happen if I pass you something like this? So I have a generator expression where I have some pre-calculated list of nodes. I want to do some filtering and then pass it into the class and create, you know, just a graph of some subnodes from that list. What's your guess as a user, right? If you see a library that documents those three possibilities, is this likely to work? Let's actually do a poll. So if you saw documentation that says those three things, do you expect this to work? So raise your hand if you expect it to work. Okay, it's about a third or a fourth. I actually probably would side with the people that say that this probably would work, because generally when I read that API documentation says that it accepts a list, I assume that the person doesn't actually mean a list and hasn't done any type checking, and so they probably will accept an iterable. So this one I probably would assume works. But the actual problem here is that we actually have to guess. Like, a quarter of the people in this room would guess yes, 3/4 would guess no, and the fact that you have to guess is the problem. Similarly, let's do the same thing. So some people find this to be surprising, some people don't, but roughly strings and lists in Python are sort of the same thing. I mean, they have different methods, but roughly a string and a list is the same sort of object. And so you pass a string that looks like this in, with the intention, let's say, being I want to create a graph with 6 nodes in there, lettered A through F. Let's do the same poll. How many people would assume that this would work? Same people, mostly because they probably read the documentation as I do. And I assume the rest of you would assume that it doesn't. And how about this one? So the problem with this one is this thing isn't an adjacency matrix, right? Someone has a dictionary. They don't actually mean that 1 is going to map to some string cat and 3 is going to map to some string dog. Someone just happened to have a dictionary that they got from elsewhere. They want to actually pass it into the function, but they want the API, let's say, to treat this as an iterable of nodes. And so they just want a graph with the nodes 1 and 3 in there. So there is a branch in those 3 that says, you know, if you have a bunch of nodes, I can create you a graph from just a bunch of nodes. But now someone who actually wants to do this, so this one, if we do the same poll, how many people would expect this to work? Okay, now I disagree, because I would assume, reading that documentation, at least personally, if I saw that something said that it takes a dict and considers it to be adjacency matrix, that probably is via some sort of branch that's, you know, saying, you know, is this an iterable? If it is, or sorry, is this a mapping? If it is, then do the adjacency matrix part, in which case that's going to probably, this object will probably hit that branch and be misinterpreted. So I would assume personally when I read that documentation that this wouldn't work, but again, the fact that we have to guess is the problem. I have an object here. I want it to be treated via one of those 3 branches. I know exactly what I have and what I want, but I'm being presented with an API that's telling me I'm going to do one of 3 things. Good luck figuring out which one it is. So what's the right thing here, or what am I getting at? So provide APIs that let users say exactly what they mean. So Python has class methods. They're great for alternate constructors. So if you want to be able to create graphs from iterables or lists or whatever, create ways of doing so that explicitly say, here's what I'm going to take and here's what I'm going to do. And don't guess that information. Same thing. You want to be able to take adjacencies, create a method that actually is going to go off and do that. So do this for each of your input formats, one for each input format, document them well, and no one has to guess. If I have a dictionary, which might not actually be an adjacency matrix, and I want it to actually be treated as an iterable of nodes, well, now I would assume if we conduct the same poll, if you saw methods that said from iterable and from adjacencies, how many people in here would assume that if you passed a dictionary to the from iterable method, that it would do the thing that you want in that case? So I hope more, yeah? Yeah. And so you have methods that better represent the actual operations that people want to perform. you'll get better results. And even your errors will be better. How many, you have APIs that do this sort of guessing, and when someone passes in an object that doesn't actually manage to catch any of the branches, most likely the traceback that you end up getting says things like, int object has no attribute iter items. And you say, yes, I know. Why were you trying to call iter items on my integer? I was trying to do x, y, z, and the API was assuming that I want to do something else. If you pass 12 into from iterable, that error message makes a lot more sense. It's going to be at least on a branch that you expect it to be taken. And the last thing to say about this is you can still get the actual thing that you might still want, which is maybe you actually do want the guesswork. So you want to provide some sort of convenience for someone who doesn't know. They're taking in some data. They don't know which form it might be in. Personally, I wouldn't do it in this specific case, but it does come up in some cases. You can still do it, and now it's just as simple. It just calls out to methods that other people can call directly. So if you know what you have, you'll be able to call directly the method that you want. If you don't know what you have, you'll be able to use some method that just does some dispatch. Just don't do it in init, right? Let people opt out, and make people have to opt in is the point for this one. So shifting gears a little bit, let's talk about something else. Resource management. So you're talking SFTP or some other thing. You want to be able to upload files somewhere. So you have this class. It's a client for your SFTP server or something, with a method for uploading your file. And ignoring issues of remote paths or whatever, you have a method. It takes a single argument, which is the path to the file on disk. Just opens the file and sends some bytes out of the file, again, ignoring how to name the file on the remote server. So what's the problem with this one? It assumes what? It assumes you can write on disk, yeah. Well, read and write, yeah. Yeah, that's probably one problem at least. Not generic enough, yes, exactly. So your object doesn't actually care about file systems, or it shouldn't care about file systems. It's not generic enough is exactly it, right? So your object here, its concerns are or should be sending some bytes around, right? It talks SFTP to some remote server, which means its core competency is speaking SFTP. It shouldn't need to know about file systems. It shouldn't need to know about taking a path on disk and finding a file on a file system. And why is that? Because I guarantee you, well, for one, when you see things like this, I think it decreases the likelihood that such an object has tests, which I would be curious to hear whether others agree. But when you see things like this, assuming that this object does have tests, if you go find them, you will find at least one place that most likely does not actually want this object to look at a file system. You'll find one place that, at least, that's trying to do something other than load a file off of disk with this object, which is an immediate example for it's not generic enough. So what's the lesson here? The lesson is don't sandwich functionality inside. Don't sandwich functionality inside resource management, right? You're going to need some resources from somewhere. Don't hide your functionality behind the actual access that's needed to get those resources. So what do you do instead? So yeah, make it more generic. There's no need to actually go off and read files in your object. Let the user worry about how to get the resources from wherever they need them from. So your upload method can just take a Filelike object, like we said before, in which case, now not only does your object not have to deal with file systems anymore, but your Filelike objects can come from string IOs, just in-memory strings. They can come from something that was loaded off a database. There's a lot more functionality that you'll get for free just by not having to deal with resources, besides the fact that that test case, which probably didn't exist before, is now more likely to exist and more likely to not involve monkey patching. But wait, possibly objects do actually have to deal with file systems, right? That's probably a fair objection. I'm sure most of the time, objects don't actually need to deal with file systems. They could just deal in file-like objects, but there are objects out there that might actually really want to talk to file systems. Fantastic. It's not actually the core idea of this talk, but now possibly this is a great example for the reason path libraries exist, right? So I think there's one in the standard library in Python 3. There are others, third-party libraries. But the exact function, or one of the functions that path libraries are trying to solve is exactly this problem. If you do have to deal with a file system, how do you represent that in a way that doesn't actually require dealing with a file system on disk? They work very simply. You have an object instead of a string that represents a path, and that object knows how to open itself. And so your users will pass in file path objects, which will actually hit disk. But in your tests, or if someone actually wanted to do something else in real life, they can pass in some path backed by a database, so that when you called open on it, it would actually go off and fetch the data from the database, or an in-memory file system that when open was called in, it just fetched some data from some in-memory object. So this is exactly why those sorts of things exist, is exactly to solve this problem of, but I really want to talk to a file system, and you still can, just don't do it with strings. So same topic. If there's anything worse than file systems, it's probably the network. So dealing with the network is even less fun, I think. So let's talk about the network. So some people possibly heard about statsd, which I think was mentioned in a couple of talks here at the conference, but it's just a simple example of a protocol. So on the left side over there is a simple statsd message. Statsd is a metric protocol, so what the message on the left means is there's some metric called request.served, which is a metric that you're going to, let's say, increment every time you serve a request. The colon is part of the protocol delimiter, and then 3 means increment this metric called request.served 3 times. Pipe C means it's a counter, so it's just going to count the total number of times that was incremented. So it's a very simple message. When you send this to a statsd server, what that means is I just served 3 requests. And the server is going to aggregate all of those and possibly display them for you or do all sorts of simple things like that. So you have this client on the right side that's going to speak statsd. It's going to talk to the server, going to send over these messages. So someone in their application is going to end up constructing one of these and calling the counter method saying, hey, I want to count some requests. So they would call the counter method, pass in request.served as the name of the metric they want to increment, and then specify a count of 3, let's say. And so what the body here is going to do is, all it does is assembles one of those messages and sends it over the network by just sort of writing it. I guess that should be, well, send all if we want to be nice. So it just writes some bytes to a socket, more or less. And what's the problem with this one? It's very similar to the problem with the last one. Your object doesn't care about the network. Or again, to be somewhat more correct, it shouldn't care about the network. And why is that? Well, to be specific about this case, there's 2 pieces of work that are being done here. One of them is very nice, and one of them kind of stinks. So protocol assembly and how to actually construct some data in a proper format is great, right? We have a ton of different protocols. Some object needs to know how to actually take the action of I want to count some requests and convert that into whatever format statsd actually is over the wire. So that part's fantastic. But actually getting those bytes on the wire, sending them someplace else, that's a mess. Why is it a mess? Because your application, your library, your statsd library, most likely doesn't actually implement a full networking stack. It's not a networking library. Your users might want to plug in their own transport methods. Like, this always comes up. For every library out there that does some networking, there's somebody out there who has wanted to use gevent to send the actual networking instead of the standard library socket, like instead of using blocking sockets, or async IO, or twisted, or tornado, or any of these things, right? Someone wants to send the bytes in some way other than how you decided to do so in your library. But when you couple the two things together, what you end up is with one object that actually combines the actual data transformation with the actual transport, which means everyone ends up re-implementing the same exact data assembly in every single client that just wants to talk statsd. So have two objects. One object knows how to construct the protocol. One object, if you'd like, implements the actual networking parts. So that the next guy who comes along and actually wants to, send some stuff in some other way doesn't need to do both parts. And your tests, again, will appreciate it because similar to what I said before about file systems, when I see something like what's on the right, it also decreases the likelihood, I think, that that object will end up having tests because sockets are even more annoying. Same thing tends to happen with API clients. Now I mean web API clients, which also I think there were a couple of really good talks on at this conference. Every API client in the world, more or less, if it's REST over HTTP stuff, there's two parts. There's one part that actually constructs some URL to hit, and then there's another part which actually does the requesting, right? So you have Facebook API, Twitter API, any of these clients, they have two parts. One of them implements the actual Facebook, Twitter API, whatever else, and the other part actually makes network calls. Split those apart, right? Have things that actually know how to implement the API from the client side, and then bolt on the networking afterwards to actually make those requests, because someone's going to want to do it some other way. Go find Twitter clients. I'm sure there are at least 500 of them, and I'm sure each one of them actually re-implement the same actual assembly of Twitter's API. Well, I wouldn't be sure, but it's definitely a possibility. So yeah, you created an API. How many of your clients actually re-implement the same simple building of URLs? So don't make them. Split it apart. People will reuse one part of it and not the other one. Let's go to another example. Now we'll actually implement an HTTP client, right? So we're going to make some requests and get back some responses. And requests and responses have a couple of attributes. Maybe they have some headers, and maybe they have some cookies associated with them. So I'm sure everyone's seen APIs that look like this. Request headers, there's just the mapping between the name of the header and the value. So this is content type plain, and maybe there's a host header. Same thing for cookies. Now there's a session ID and a color preference. The problem is that that's not actually a proper representation of either of those things, because headers and cookies aren't actually unordered mappings of string value pairs. But the person that's doing that isn't actually trying to be malicious, right? There's this fight between convenience and the compromises that you have to make, right? So for example, headers are, well, when they come in off the wire, they're ordered. And also, you can have multiple repeated of the same header, right? You can have multiple lines with the same header, and HTTP as a specification defines what to do and how to combine those and all of those things. So it's not actually a one-to-one mapping. It's not actually, it might be unordered by the specification, but it still might be useful to know what the order was when it came in, all of that thing. And so someone who's designing an API that does these sort of things is probably trying to make it convenient, because in 99% of the cases, most likely that's an acceptable compromise to make. But if you provide convenience, provide it as a layer, right? So similar to the ideas before, if you're providing an API for accessing cookies, and you want to do that in a convenient way, to be able to access the cookies just by specifying the key and getting back the value that was in the request or the response, have it be a layer, right? Provide access to the actual underlying thing. So you may have seen the cookie-lib standard library module, specifically the cookie jar object in there. Cookies have a bunch of other values associated with them, right? So a cookie has an expiration date, potentially. It has a domain that it's associated with. All of those things are metadata besides the actual value of the cookie itself. So don't hide details when you're providing convenience layers. Provide a convenience layer, but still give access to someone who actually needs something else other than what your layer provides. So satisfy the 99% case in a way that also lets someone get at what they need if they have to. Because it's better, if you're providing abstraction layers, it's better to provide at least a leaky abstraction layer than just a bad abstraction layer that you don't actually have any way of avoiding. Last one. So how many people have seen APIs that do something clever like this? So now maybe we're implementing CSS Selection. It's going to go find some elements on the page. And the way that hypothetical API works is you say css.byId, and then the thing that you put after that is the actual name of the element that you're looking up. Have people seen APIs, not necessarily for CSS, but I assume in other domains that do things like this? Yes, I assume. Yeah, decent smattering of hands. So these are all of the, well, some of the things that can go wrong just from 2 minutes of thinking about it, right? So are all of the things that you need to access valid Python identifiers? If they're not, well, now your quote-unquote pretty-looking API that was like css.byid.whatever becomes a not-so-pretty API because anyone who wants to access a CSS element whose ID is class for whatever reason needs the getAttr function call. So just something very simple like, does the actual set of valid things match up with a set of valid Python identifiers is just one thing. What happens when you access a non-existing attribute, right? So you have an API that looks like this. You access, css.byid.foobar, which doesn't actually exist on the page. What's your prediction as a user? What error will you get, right? So again, predictability. You try to access an attribute that doesn't actually exist on the page. What's your guess? And there's two choices. I assume probably most people would go one of those two ways. One is you get some specific application error that says no such CSS on the page, but the other one is attribute error, which we're used to getting for all sorts of missing attribute things, right? So again, you have to guess. You provide an API where someone is most likely going to have to guess what they're going to get. And what happens when you accidentally pass your object to something that's doing some nasty dispatching, or not even nasty dispatching, but trying to access attributes on random objects? So for example, a common example of things that do this are editor tools that are trying to do some runtime things, right? They try to poke at random attributes on your object and check to see if the attribute is there, and if they do, they do something, right? So your object, which might actually return for any attribute might actually return an object, is going to just utterly confuse that object and any API that just randomly tries to access some stuff on your object. And of course, things that are trying to access random attributes aren't the greatest thing in the world either, but they definitely exist. And even worse than that, for general API stuff, what happens when you need to add a specific attribute, right? So you forgot that you need some specific method, but there's no way of actually adding that without breaking backwards compatibility, because whatever you add, that's a thing that someone could have already decided to use as a CSS selector or in whatever other form this API takes. You just can't add it and not break backwards compatibility. What happens when you need to parameterize how you actually access the specific thing, right? This happens with properties as well, with the property decorator. Usually you were accessing the specific element, but now you figure out that there's some parameter that actually you want to use to control something that happens during that access. Again, you have no way of actually implementing that because you've just used attribute access. There's no actual parameter passing, so you just can't. And ultimately, the reason why not is just like, what's wrong with this? There's nothing particularly ugly to me about just passing arguments to functions. So just to summarize, convenience is awesome. Everyone should make their libraries convenient. All of these things are fantastic. Just don't sacrifice your users' predictability or the ability for them to come on and extend what you have. Choose the right interface for your problem. And stay away from file systems, networks, databases, all of those things. Let other people have to deal with those. That's it. Questions? Thomas?
Maybe rather comment.
Sure.
There is this PEP 8 standard, and people have some sort of expectation that the API names are as usual, basically. And if you follow PEP 8, maybe most people will agree with the names and not have to rename your names in your API.
Yeah.
Not a question, just a comment about type checking.
Please.
One thing where you might need it, if when your function accepts the iterable and you might want to check that it's not a string, because otherwise you might end up sending emails to Rob Pike who happen to have one-letter username.
Yeah.
Is there any other questions?
Any others? Comments or questions? No. Really, that was as agreeable as, that was way more agreeable than I expected. Yeah.
What you mentioned is a comment, but it's like what you mentioned about resource and how you handle the resources. That can be extended to any situation. It's like it's called separation of concern.
Yes.
So you don't. That's a object-oriented design principle. So it's not only for resources, but by anything. One class should be one particular job, not opening files. Only either opens the file or sends the file. That's it.
Yeah, I think the only specific reason why I didn't just write separate your concerns is because I think when you say separation of concerns, for specific things like the file, like files, networking, like it's important to just be very specific that like literally anytime you have to deal with file systems or the network or sockets, I think it's probably a moment of pause, whereas separation of concerns is sort of like a general thing I think we all try to keep in mind. But it's easy, or it's beneficial, I think, to have like specific touch points that say like, oh, I'm about to define an API that takes path as a string. That probably means I'm doing something wrong and I should stop. But yeah, I agree. It's covered under separation of concerns.
Hi. So you mentioned separating the protocol and the transport. And do you have any examples of some libraries that do that correctly, so I can learn from that? It sounds like a good idea, but I'd be curious how to go about doing it correctly.
So there probably, well, possibly are some twisted devs still here, maybe. So the real answer to your question is no, not really, except in one sense. So the reason why I brought that up is that there are some libraries that use like, or there was a push at one point to start using like actual context-free grammars to do parsing of protocols, in which case, if you actually encapsulate that part, then yeah, that part's gonna be reusable. So I can hunt one of those down and pass that along to you. That would be one example of a place that would actually be separating how to parse or create the actual protocol language itself from doing the actual transport. So no, unfortunately, I don't have very many good examples. I wish there were more.
Just another comment about a file system example. There's another bad effect of doing that. If you open the file inside your function, you maybe, if you return to the upper layer, you maybe have to reopen it again due to some other reason, or even you had it already opened and you need to close it, and so it's just on the wrong layer.
Yep, and in the same vein, I can't even count, it's probably 3 or 4 at this point, the number of libraries that I've had to fork and patch, because not only were they doing resource management inside some function, but they were doing it incorrectly without using the with statement, which causes nasty things on PyPy, used to blow up file descriptors and things like that for us, so just don't do it.
Is there any other questions? Okay. Thank you very much.
Cool, thanks.